So let's look at an example of natural selection in action with this cartoon example. Here we have individual bugs within a population, so all members of the same species, that are variable in some way. We can see we've got some green bugs and we got some red bugs here. So the thing is, that trait of having green or red pigment in them has to be heritable in some way, meaning it has a genetic basis, and therefore you can pass it on to your offspring. Not all traits can be passed on to your offspring, right? If you dye your hair blonde, it doesn't mean your babies are going to be blonde. That's an environmental effect on your physical characteristics, okay? In this case, these pigments are heritable and they can pass them on to our offspring. Okay, notice we've got 3 green bugs and 3 red bugs. Okay, now, the next piece that's important is that interaction with the environment, right? So the trait that they're displaying, being green or red, is influencing the way that this bird is going to prey on them. Okay, so our bird predator is going to be able to see one of these colors better than the other. And in our example here, we're assuming that the bird can actually see the red color better. So if you're a bird and you're going out to eat bugs and you can see the red ones better, you're probably going to eat them, right? So who's going to survive better, right? So in this case, the red ones are going to get eaten, or at least some of them. Maybe they don't all, but let's say 2 out of our 3 red ones get eaten. The green ones are the ones that survive, right? So if you're the one that survives, you can also go on to do what? To reproduce, right? So this is what I mean by this relationship between the trait, in this case having green or red color, and some measure of survival and or reproduction. So the trait being red makes you less likely to survive in this example, okay? So notice that if you survive, you're also going to be around to reproduce, even if every bug produces the same amount. And in this example, we're saying, let's say every one of our survivors has 3 babies, okay? So we went from a population where we had 3 green and 3 red, so they were 50% green to 50% red. Now we've had a round of reproduction. All the green ones reproduce, all the red ones reproduce. Now we have 75% of our bug population is displaying this green phenotype, and only 25% are red. So we went from 50-50 green to red to 75 to 25 green to red. That's evolutionary change. Remember what I said evolution was? A genetic change in a population over time. And look, within just a generation, we can see that there's a difference in the frequency of those genes that code for these different pigments in our bugs. So this is an example of evolutionary change. Let's look at another example, very similar to this one. And here you can see that you've got some beetles that have either black spots on them or they're just plain. And here, instead of just one generation, like in my last example, I've got several rounds of reproduction here. So generation 1 to generation 2, generation 3, generation 4. Okay, so here we have 1, 2, 3, 4. Okay, so who's surviving? Who's reproducing? Okay, in our example here, the beetles that don't have as many of the black spots are the ones that are surviving better and therefore reproducing. So again, genetic change in the population is happening over time. We went from 50-50 to 40-60 to 30-70 to 10 and 90 to 100%. Okay, in this case, one of them went completely extinct. But they don't have to for evolutionary change to have happened. We just see that genetic change in the population over time. Okay, in real populations, over many, many more generations, right? We may be thinking more about having just many generations over hundreds of years, thousands of years, tens of thousands of years, long periods of time where the result of many rounds of natural selection is that you get very refined adaptations, okay? And these extreme examples of these tropical mantids where they've come to look exactly like their background because the predators, maybe birds, maybe other predators, are eating the mantids that look less like their background, right? Picking out those until the ones that survive, the ones that reproduce, are the ones that look like their background. And we have these amazing examples of evolutionary adaptation and specialization. Even that one on the end there that looks like there's only an orchid in the picture, there's actually a mantid there. Pause the video and take a close look at that. There's actually an insect in that picture too.